In this question, we're given this magical equation, 2 moles of dinitrogen pentoxide forming 4 moles of nitrogen dioxide plus O2 gas. I'm not honestly going to write down the physical states, they're all gases in this case. It then asks us what the rate of formation of O2, or sorry, it tells us that the rate of formation of O2 is, my mistake, 2.2 times 10 to the negative 4 molars per second. Molars. And then asks us what the rate of decomposition of this is at the moment in which the rate of formation of O2 is that. So you might remember me discussing this earlier in a previous lecture, that the relative rate law equation for each of these components is 1 divided by the coefficient, in this case 2, multiplied by the change in concentration of N2O5, divided by delta T is going to be equal to 1 divided by the coefficient 4 multiplied by the change in the concentration of NO2 divided by delta T, which is going to be equal to 1 divided by the coefficient in front of O2, which is 1, multiplied by the change in the concentration of O2 divided by delta T. Hopefully that all makes sense. So, what it's asking me in this question is to determine what this is when this is equal to 2.2 times 10 to the negative 4th molars per second. Hopefully that makes sense. Once again, at some moment in time when this reaction is proceeding, the rate of formation of O2, that's this thing, is equal to 2.2 times 10 to the negative 4 molars per second. And it's asking me at that moment, what is the rate of decomposition of this? So I can, and this component I can kind of ignore because I don't really have to have it since each of these components are individually equal. If I have any one of them, I can determine the other. So I'm going to replace this with x, and I'm going to say negative 1/2 times x is going to be equal to 2.2 times 10 to the negative 4 molars per second. Really, all I have to do is solve for x, and that will give me the answer to this question.